Hi guys, my name is Dr. Norpadzlihatun Manap and I'm a visiting researcher at the Center for Environmental Policy, Imperial College London. Today I'm going to share with you guys about scientometrics analysis using VOSviewer, a common software for analysis, mapping and visualization of literature. I reckon you are at the starting point of your research. I hope this presentation helps you to better understand your research area. As you can see in this diagram, it is one of the outputs from VOSviewer of which can help you to perform the literature review. The diagram shows journals which have been categorized according to its disciplines. You can see different colors and sizes of bubbles that represent each journal cluster and impact. From this diagram, there are 7 clusters with 7 different colors, symbolizing each discipline the journal belongs to. For example, Annals of Neurology and British Journal of Pharmacology belong to the same green cluster. This green cluster represents the discipline of neurology. You can also see the difference in the size of the bubbles. The bigger the size, the higher the impact of a journal. The impact here can refer to many indicators, including number of citation or number of documents a journal possessed. By having this cluster and impact, it helps you to have a better understanding of your research, which is critical at the start of your journey. This presentation has 7 different segments, as can be seen in this outline. The first segment is introduction, of which I will explain what is scientometrics and what are its related terms. The second segment is purpose. I will share with you guys why we need to do the scientometrics analysis. Then I will share with you what are the softwares that we can use to analyze, map and visualize scientometrics data. I will later on explain why I use VOSviewer instead of other available softwares. The following segments will be a bit technical, where I show you guys how to use VOSviewer by sharing its user interface and the file types that can be analyzed in this software. Last but not least, I will show what are the references that I used in this presentation for reading at your own time. In this first segment, I'm going to introduce what is scientometrics. Have you heard of this term before? This term is very popular among information and library scientists, but it is also useful to researchers in many disciplines. Scientometrics is a field of study related to measuring and analyzing scientific literature. It can also be defined as a quantitative method of research on the development of science as an informational process, as defined by Nalimov and Molchenko in 1971. Mingus and Ledesdorf in 2015 have a similar definition of this term, but relates it to the study of quantitative aspects of the process of science as a communication system. There is a significant overlap between scientometrics and other scientific fields, including bibliometrics, infometrics, webometrics, and altmetrics. Bibliometrics is the application of mathematics and statistical methods to books and other media of communication. Infometrics is the study of the application of mathematical methods to the objects of information science, while webometrics is the study of the quantitative aspects of the construction and use of information resources, structures and technologies on the web, drawing on bibliometric and infometric approaches. Last but not least, the altmetrics is the study and use of scholarly impact measures based on activity in online tools and environments. The second segment is about why we need to perform scientometrics analysis. From previous slides, we understand that scientometrics relates to information and communication of science. To date, there are many publications and it will be quite confusing, especially for beginners, to find high quality and relatable scientific papers. So, scientometrics analysis will help to get a clear idea of a scientific field by mapping and visualizing scientific fields. It will also help researchers to measure and evaluate research performance. Scientometrics analysis also beneficial to decompose scientific literature into disciplinary and subdisciplinary structures. In general, it is performed to understand the structural, temporal, and dynamic development of a discipline. The third segment will explore what softwares can be used to analyze, map, and visualize scientometrics data. Previous researchers have used many softwares that mostly can be downloaded free of charge from the web. Among these are SciMat, NoteXL, VOSviewer, UCNet software, Gephi, Pajak, Network Workbench, HisSite, and also R Project. In this slide, I have listed the website address for each software that I mentioned. You can Google the name of the software or simply copy and paste the link I provided. Please have a try to explore all the softwares and find which one that suits you the most. In my case, I prefer VOSviewer to analyze, map, and visualize my data. Why I choose VOSviewer? Well, from my experience and from my reading, I find VOSviewer as user-friendly, and it also has many visualization options. It makes it easy for co-citation, co-author, or any other analysis deemed necessary for me to understand my research discipline. However, as any other softwares, VOSviewer too have some weaknesses. It is not suitable to perform for only citation analysis, and sometimes clusters may be a bit confusing. If you want to have a read on strengths and weaknesses of each software, please explore the Research Hub, accessible at the website address as I enlisted in the reference slide. The fifth segment will be about the VOSviewer. The notes that I provided in these slides are taken from the VOSviewer manual written by Van Eck and Waltman. VOSviewer is a software tool for creating maps based on network data and for visualizing and exploring these maps. This software tool functions as to create maps based on network data and also to visualize and explore maps. The diagram provided here shows the latest version of VOSviewer, that is 1.6.14. This software tool is created by Nis Jan van Eck and Ludo Waltman. This software tool is permitted, free of charge, to be used and or distribute, provided that the copyright notice and the permission notice are retained. If you notice, recently many publications have emerged that review the dynamic of a research discipline. Many of these publications use VOSviewer to analyze big data that gathered since many years ago. Data review from many years of publications in a research discipline can help researchers to look for a trend and anticipate its way forward. This enables young researchers to have a focus since the beginning of their research. Many research disciplines have gained benefits from this effort, as can be seen in this graph. It shows the percentage of research that used VOSviewer in the Web of Science categories. The research gathered, analyzed, and shown here was since 2009 till 2020. It shows that 21% of research in the category of information science and library science have used VOSviewer since 11 years ago. This graph also shows that research in categories relate to environmental science, engineering and medicine have not yet to have many research using VOSviewer in recent times. For example, only 9% of research that use VOSviewer since 11 years ago in environmental science, and only 1% of research that use VOSviewer in automation control systems discipline. This concludes that there is still opportunity to publish reviews using VOSviewer in the categories mentioned. Before we start to use VOSviewer, we need to understand the terminologies used in this software tool. I will share the most common terms, and if you require further information about any terms in VOSviewer, the manual could provide such information. The terms that I'm going to explain using example includes items, link, and strength. Other terms also include network, cluster, weight, score, and total link strength. This diagram shows an example of VOSviewer output. It shows a network map of the main focus area of sustainable construction studies. The bubbles represent terms commonly found in sustainable construction studies. In VOSviewer, items mean the objects of interest. As can be seen in this diagram, items are bubbles that represent the object of interest. For example, sustainable development, concretes, and recycling in this diagram shows the objects of interest. In this case, my interest is on the main focus area of sustainable construction studies. Link means the connection or relation between two items. As can be seen in this diagram, the term global warming and energy utilization have a relation that's symbolized by a line that connect these two items. Strength may indicate the number of cited references two publications have in common for the case of bibliographic coupling links, or in the case of co-authorship links, it indicates the number of publications or two researchers have co-authored. If it is the case of co-occurrence links, it indicates the number of publications in which two terms occur together. Referring to this diagram, the strength of the link between two items, for example, global warming and energy utilization, refers to the number of publications in which these two terms occur together. As you can see, there is a difference in the width of the line that shows the strength of the link. The link between project management and sustainable construction have a wider width of line to compare to the width of the line that connects global warming and energy utilization. This means that the number of publications that occur in global warming and energy utilization is lower than the number of publications that occur in project management and sustainable construction. It also means that the strength of the link between global warming and energy utilization is weaker to compare to the strength of the link between project management and sustainable construction. The weak link or the low number of publications that global warming and energy utilization occur together shows that there is a research gap that links these two terms together. It is an opportunity for researchers to focus on in this discipline. Network is a set of items together with the links between the items. This whole diagram is called a network. Cluster is a set of items included in a map. As you can see in this diagram, there are three clusters, differentiated by three colors, red, blue, and green. It shows three subdisciplines of sustainable construction studies. You can adjust the clustering resolution to make it simpler or to have a more detailed subdisciplines. In VOSviewer, you need to name the clusters by your own. In my case, the red cluster is named as the Sustainable Construction Methods cluster, the blue cluster as the Recycling and Waste Reduction cluster, and the green cluster as Sustainable Construction Material cluster. Weight may indicate the importance of the item. In the map, items with a higher weight are shown more prominently than items with a lower weight. Score may indicate any numerical property of items. Score attributes are considered only in the overlay visualization of a map. Since weight attributes are already used to indicate the importance of items, it is recommended to use score attributes to indicate other properties. Total link strength indicates the total strength of the links of an item with other items. The sixth segment will concentrate on the user interface of VOSviewer. The diagram shows the user interface, which consists of 5 panels. The first panel is the main panel. The second panel is the options panel. The third panel is the information panel. The fourth panel is the overview panel, and the fifth panel is the action panel. The first panel is the main panel. Main panel presents a visualization of the currently active map. There are 3 visualizations in this panel. First is the network visualization, second is the overlay visualization, and third is the density visualization. The second panel is the options panel. If network visualization or overlay visualization selected, adjustments can be made to the visualization of the currently active map presented in the main panel. These adjustments includes visualization, labels, lines, or colors. If density visualization selected, adjustments can be made to the visualization of the currently active map presented in the main panel. Adjustments can be made on visualization, labels, density, or colors. The third panel is the information panel. This panel presents descriptions of items in the currently active map. It is available only if items have a description attribute. The fourth panel is the overview panel. It presents an overview of the currently active map. Each item in the map is represented by a small colored dot. The fifth panel is the action panel. This panel consists of 3 tabs: File, Items, and Analysis. The File tab to perform a number of basic actions. Map and info buttons can be found in this tab. The Items tab presents a list of items in the currently active map, and the Analysis tab is to update the layout and the clustering of the currently active map. Buttons include normalization, layout, clustering, and a rotate or flip can be found in this tab. It is easy to create map using the Create Map wizard. In the Create Map wizard, there will be 3 buttons that allow you to create a map based on network data, bibliographic data, or text data. If you want to create a map based on a network data, VOSviewer needs to be provided with information about the items in the network and the links between the items. On the other hand, if you want to create a map based on bibliographic data or text data, first a network is constructed based on the data that is made available to VOSviewer, and then a map is created based on the constructed network. There are options that you can choose in the Create Map wizard. If you want to create a map based on network data, your data source should be from VOSviewer, GML, or project files. If you want to create a map based on bibliographic data or text data, you need to have bibliographic database files or reference manager files or application programming interfaces files (API). If you want to create a map based on bibliographic data, you can create 5 types of links between items to be analyzed. These include the co-authorship link, the co-occurrence link, the citation link, the bibliographic coupling link, or the co-citation link. Based on the type of links that you analyze, the output of your analysis will vary. The analysis output, which is the items of interest, can be the authors, organizations, countries, keywords, documents, sources, cited references, cited sources, or cited authors. If you want to create a map based on text data, you can create the co-occurrence link, and the output will be the terms. It is important for you to know that VOSviewer supports bibliographic database files from Web of Science, Scopus, Dimensions, and PubMed. Reference manager files from EndNote and RefWorks are supported, in addition to RIS files. Supports the APIs of Microsoft Academic, Crossref, Europe PMC, Semantic Scholar, the Open Citations Corpus, OCC, the Open Citations Index of Crossref Open, DOI2, DOI Citations, COCI, and Wikidata. Bibliographic database files, reference manager files, and APIs can also be used to make text data available to VOSviewer. Text data is obtained from the titles and abstracts of documents. Web of Science, Scopus, and Dimensions impose download restrictions. File downloaded from Web of Science and Scopus may contain data for at most 500 and 2000 documents, respectively. In order to work with data for a larger number of documents, the data needs to be downloaded in multiple batches. Each batch needs to be saved in a separate file. As mentioned, there are 5 types of analysis for bibliographic data. The first type is the co-authorship analysis. The relatedness of items is determined based on the number of co-authored documents. The second type is the co-occurrence analysis. The relatedness of items is determined based on the number of documents in which they occurred together. The third type analysis is the citation analysis. The relatedness of items is determined based on the number of times they cite each other. The fourth analysis is the bibliographic coupling analysis. The relatedness of items is determined based on the number of references they share. And the last type of analysis is the co-citation analysis. The relatedness of items is determined based on the number of times they are cited together. Hi guys, so I'm going to share with you guys how to export bibliographic data from Web of Science to VOSviewer. Okay, I'm going to use sustainable construction to search from all fields and from last 5 years. So as it is too much, the result is 15,000. For the sake of this presentation, I'm just going to refine it to open access. Alright, let's just say that I want to export 5,899 papers in sustainable construction into VOSviewer. So what I want to do first is I want to export these files to other file formats. Okay, and then I select records from 1 to 500. Okay, this is because VOSviewer only analyze maximum of 500 files from Web of Science. From Scopus, the maximum number is 2000. So we need to do it in batches. If you have 5,899, so you have like 10 or 11 batch, which you need to do this step repeatedly. Okay, so start with selecting the records from 1 to 500. Select record content of full record and cited references, and file format, you need to be sure that it is in the tab delimited win format, and then export. Make sure that it is exported. If you are sure it is exported, then just close it. If you are not sure, then just export it again. Okay, now I'm sure that it is in exporting process, so just click X. I need to repeat the steps again. Okay, but this time I need to put the records from 501 as we have already export the first batch 1 to 500 previously, so we need to do the second batch, which is from 501 to 1000. The same record content and the same file format. Export. Make sure that it is exported. For the sake of this presentation, I'm just going to do one last time. Okay, so last time is 1000, but we need to do it 1001 to 1500. Select record content, tab delimited, win, export. Okay, make sure that it is already exported. If not, then just export it again by clicking this button. Okay, go to the download folder. Okay, and cut and paste whatever that you have already downloaded into a folder that is easy for you to retrieve. Okay, in this example, I'm just going to put it in example 1 folder. Okay, now you have already finished all your batches. You have 10 batches there. You need to open the VOSviewer software and create a map using the create map wizard. Okay, you have to choose the bibliographic data because it is not a network data, and then it's not text data because you have already exported it from a bibliographic database, which is Web of Science. So select the bibliographic data, and as it is from the Web of Science, then click the read data from bibliographic database files. If you have it in your reference or EndNote, then put it there. So in this case, in this example, I take it from Web of Science, so I'm just going to go with the button of read data from bibliographic database files. Okay, and then I retrieve back from example 1. So copy everything and select OK and go next. Let it read till it finish. So here you can choose your type of analysis and your counting method. You can go to you can choose whatever analysis that suits to your needs. Okay, you can go and choose co-authorship, co-occurrence, citation, or bibliographic coupling, or co-citation. And you can also choose for each analysis your unit of analysis. For co-authorship analysis, you can choose the authors, organizations, or countries. For citation, you can choose the unit of analysis of documents, sources, authors, organizations, countries. And some of the analyses have options of counting method. Okay, you can read it. What is the definition of each counting method, and choose whatever that suits you. Okay, for this example, I'm just going to go with the co-occurrence and choose author keywords. This is random, for example. Okay, after I choose my type of analysis and the unit of analysis, I can choose the threshold. So from my data, I have 5,217 keywords. So I can set the minimum number of occurrences of a keyword that I want. So if I choose the default number, which is 5, out of 5,217 keywords, 87 keywords meet the threshold. If I make it higher, then the lesser keywords that meet my threshold. So I'm just going to go with the default number. I can also choose, if I'm not satisfied with the default number and I cannot change it with the minimum number of occurrence, for example, like 87 is not a good number for me, so perhaps I want to have 90, then I can change it. And I can also verify my selected keywords by selecting or deselecting it. Okay, I can also organize the keywords according to occurrences or total link strength. Here, if I want to look at higher occurrences, I can change it to ascending or descending. This is important because perhaps the keyword is too general. For example, like sustainability, so of course it's going to have higher number of occurrences because it's very general to compare to, for example, like engineering or maintenance, solid waste, which is a bit detailed to compare to sustainability, so it has lesser number of occurrences. So I can just stick sustainability. What it does is, if it has highest number of occurrences and it is general, it can makes it it can deviate you from the keyword that you want to know, a bit more detail and a bit more how can I say? Yeah, it's general. It's very general. So I'm just going to deselect it. Okay. So finish. Okay, you have an option to show whether you want to have the largest set of collected items consists only 79 instead of 90 that we set previously. So I have an option whether I want to show this set or not. So okay, I selected yes. So here is all the keywords based on the co-occurrence analysis of sustainable construction data. So from here I can see there are a couple of colors, a couple of colors, and quite a number of bubbles which differentiated by color by colors and size. So from the first perception, I can say that the keyword sustainable development is the keyword that has the highest occurrence in sustainable construction. Likewise, construction, climate change, compressive strength, concrete, and sustainable construction. Okay, remember the first thing that we did in this video is to search sustainable construction. And no wonder that the sustainable construction and the sustainable development, which is really relates to the keywords that we select in the Web of Science, have the biggest circle in this VOSviewer, because that is actually the keyword that we use to search. So it is very important for us to deselect the keywords which is very general, because you cannot see any other keywords that is useful for you if you have all the similar keywords that you use in Web of Science. So you need to deselect general keywords like sustainable construction, like sustainable development, like construction, so that you can see what are hidden behind. For example, like sustainable construction, sustainable development. Okay, previously you did not see engineering, conservation, biodiversity, decision, multi-criteria decision analysis, because sustainable development is hiding it all. So it's very important to select or deselect the correct keywords. Alright, so you can change whatever that you have in this network visualization using all the buttons that you can have in this panel. You can change the scale of the visualization. You can make it bigger or smaller. You can change the weights, whether you want to have it in occurrences, links, or total link strength. You can change the labels, make it smaller or bigger. You can change from circles to frames. I like circles more because I can see a bit more of information from these circles. And I can also have max length. I can make it with different fonts. Okay, amber. It doesn't change anything apart from font. And I can also change the variation of sizes of lines. So lines, remember, lines indicates the strength between two items. So if the width of the line is wider, so it means the strength is stronger. So you can set the threshold for minimum strength and max lines, but I just go with the default values. I can also change whether I want to have colored lines or just uncolored one, and I have options to set whether I want to curve lines or not. And if I like, I can also change the background to black. Okay, this is network visualization, of which the colors symbolize the clusters. So here I can see at least 1, 2, 3, 4, 5, 6 different clusters. Okay, we go next to the overlay visualization. Here, okay, you can put another importance, another property to set the importance. Okay, in network visualization, the weight is on the occurrences, means that you can see the difference of importance based on the size of the bubbles. But in overlay visualization, you can set your importance to other properties. In this case, you can set whether you want to have another property to look on, to set the importance based on publication, average publication year, or average citations, or average normalized citations. Okay, normalized citation and citation is different. You can have the definition by reading the manual. Alright, so in this overlay visualization, the colors symbolize the scores that you put, and the scores here means the average publication year or average citation. Okay, let's say that I want to look at the properties of average publication year. Okay, so the sizes remain the same like network visualization, because the first thing that I want to analyze is the occurrences, so it wouldn't change, but the colors changes. The colors change because I put the scores as average publication year. It means that I can do two analyses in one time. I can look at the weights, I can look at which keyword have the most occurrences or the least occurrences, and also I can analyze this data based on when it is published. If it is in yellow, it means that it has been published recently. But if it's in darker color, like purple, it means it has been published early. So I can say that sustainable development, the keyword of sustainable development, has been published quite early compared to sustainable construction, and therefore it has higher number of occurrences. I can also check the average citation. So instead of year, average publication year, the scores here have changed from year to average citation. Yellow, the lighter color, shows higher average number of average citation. The darker color shows the lesser average citations. So here we can see that compressive strength has lesser average citation compared to climate change, which has higher average citation. Okay, so this is overlay visualization. Density visualization is the visualization that I can look at right now. Okay, I can see that sustainable development is still the highest and the most, the keyword that has most occurrences. I can change it from having cluster density to item density, so I can have a look at the density of each keyword. I can say from this visualization that sustainable development has a very high density compared to circular economy, compared to rheology waste. So if I want to focus on a new research that is with lesser density, I can opt to do research in perhaps building information modeling or sustainable construction, ecosystem services. Or if I have if I want to have more references to read, means that more research that have been done in using sustainable development or life cycle assessment, I can choose the highest density. Okay, so I can change, go back to the network visualization, I can change the number of clusters that I want. Okay, and I just go to the clustering resolution. I want to make it perhaps 0.5. Let's see what is changed. So from 7 I can only have 5 clusters. Okay, it makes it more easy to represent back in my papers, in my thesis, in my chapters, because we need to rename the clusters. And if you have too many clusters, then for example like this, you have like more than 10 clusters, it makes it hard for you to name each cluster. Okay, perhaps you want to know each item in detail. You can just go to the items and select energy perhaps, and you can look where which items that is connected to energy. In here you can see it connected to environment, construction, and civil engineering and whatnot. Okay, so you can see also that the details of energy is located at the far left bottom. Okay, it shows that it belongs to cluster number 2. It has 6 links. The total link strength is 7 and the occurrences is 10. Right. So if you want to copy and paste this diagram, you can take a screenshot. Okay, you can whether save it, print it, or clip it, copy to clipboard, and you have options, okay, to do whatever that is provided there. Usually I copy to clipboard and paste it. So there you go. So you can start writing in your Word document. So I think that's all. That's all of my presentation for VOSviewer. Thank you for listening, and I hope whatever that I've shared today helps you. And good luck.